Hi everyone, it is Sri Devi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. In this video lecture, we are going to learn about interference and system capacity of a cellular channel. On completion of this module, the learners can able to understand the concept of channel interference and system capacity. So, before starting the lecture, we have to know what is an interference. Interference is nothing but mixing of frequencies from one cell to another cell. It is called as interference. So, in cellular concept, different cells using different frequencies, they are mixing of or interfering. A major limiting factor in this performance of a cellular radio system is interference. It has been recognized as a major problem to block the capacity. And two major types of system generated cellular interference are co-channel interference and adjacent channel interference. Both are different types of interferences. Co-channel interference means the cells using the same set of frequencies are called to cells, and the interference between signals from these cells are called as co-channel interference. That is, cells using the same set of frequencies are called as co-channels. So, same frequency set of frequencies are interference. Unlike thermal noise, here it can be overcome by increasing the signal to noise ratio. The co-channel interference cannot be combined by simply by increasing the carrier power of the transmitter. This is because an increase in carrier transmitter power increases the interference of neighboring co-cells. To reduce the co-channel interference, co-channel cells must be physically separated by a minimum distance to provide the sufficient uh, duration of time. So, co-channel interference is simply defined as the ratio. This ratio is the function of radius of cell and the distance between the centers of the nearest co-channel cells. It is called as co-channel interference. It is represented by the letter capital D. By increasing the ratio D by R is the radiation, R is the radius. This ratio, if it is increased, the spatial separation between the co-channel cells are which are covering the distance of the cells is also increased. So thus interference is reduced. So this is known as the co-channel interference. Co-channel reuse ratio. What is co-channel reuse ratio is the parameter Q equal to D by R, that is called as the co-channel reuse ratio. It is related to the cluster size n. So to make a cluster n, there is the minimum of 7 cells are needed. So it can be seen that 7 cell cluster with the mobile unit, it is the cell boundary. The mobile is the mobile is a distance dr. Then we can see the 7 cell reuse structure here. So why we are choosing 7 cells is it is the basic count n value to make a cluster. So here d is the distance and r is the radius, and d plus r is the distance from the point to the center of the hexagon. From the two nearest co-channel interfering cells, and approximately d plus r by 2 and d minus r by 2 and also d. With the d plus r from the other interfering cells is the first tier, and n equal to 4, and signal to interference ratio for the worst case can be written by signal to noise ratio S by n equal to r power minus 4 divided by 2 into d minus r. D minus r is the distance, diameter plus radius, which is taken as minus value, and also it is taken as plus value. So 2 into d plus r the whole power minus 4 plus 2d into d power minus 4. This is called as signal to noise ratio. For n equal to 7, the co-channel interference reuse ratio is q equal to 4.6, and the worst case it is signal to interference noise ratio is 49.56 dB. When the size of each cell is approximately the same, the base stations transmit the same power when the same value Q provides the larger capacity of the cluster size n. So signal to noise ratio, it is represented by S by summation II, average received power P, and the distance from the transmitter and array is approximated by this signal to noise ratio. It is the co-channel interference base station value. Adjacent channel interference means the channels resulting from signals which are adjacent in frequency and decide is called as adjacent channel interference. That is adjacent in frequency. Adjacent channel interference results from the imperfect receiver filters. So the problem can be particularly serious if an adjacent channel user is transmitting a very close range of subscribers receiver. So there is one problem which is called as near far problem. When the frequencies are coming closer, that is called as the near problem, and they are separating each other, that is called as far problem, that is called as near far problem. The base station may have differently in determining the mobile user from adjacent channel mobile. So we can find the signal to noise ratio S by I as 20 power minus n. So here 20 times as close to the base station, and another mobile is as the energy spill out of its pass band. So this is simply called as basic cellular concepts and adjacent and co-channel interference. Thank you.